Hello everyone, in this video I'm going to solve one of the questions from your notebook. So the situation is a block that is sliding across the surface and there is friction on that surface in this case, but it's not sliding at constant velocity, it's accelerating at 0.5 meters per second squared. So the first thing is to identify the object we're going to work with. So we put a circle around the block, which is what we need to investigate. And the first step, obviously, because we're doing mechanics, is to do the free body diagram. In the free body diagram, the first force is going to be the force of gravity, then the applied force of 75 newtons, and the support force. And you can see that the support force is bigger than the weight in this case because of the 75 newton that is a bit at an angle downwards, okay? And again, and there is the friction force. So we're going to start by looking at the horizontal motion. And because the horizontal motion is accelerated motion, we're going to have that on the x-axis, F net equals ma. So what are the forces on the x-axis? We have the horizontal 75 Newton force, but the horizontal component, which is 75 cosine 23, minus the friction force equals ma. So 69, if you calculate, minus F equals 6.25. So if we rearrange the equation, we get the friction is 69 minus 6.25, or friction is 62.9 newtons to the right. Okay? So pay attention that I've drawn a reference frame in gray, X and Y. For the second part, we're looking for the support force. So the first support force is going to be identified by looking at the y-axis. On the y-axis, there's no motion. So we can say that on the y-axis, the net force equals 0. So what are the forces on the y-axis? We have R upwards in positive, mg downward, which is minus mg, and the y component of the 75 Newton force, which is 75 sine of 23. And that's going to be equal to 0. We rearrange the equation, gives us R equals mg plus 75 sine 23. And then we replace with the values to be able to calculate the support force.